Welcome to the Deep Dive. We're here to help you cut through the noise and get truly well-informed fast.
Yeah, there's just so much information out there, isn't there? Especially in tech.
Exactly. Like with cloud technology, new stuff pops up constantly. It's hard to really grasp the core ideas without getting totally bogged down, whether you're just starting or, trying to keep up.
Mm-hmm.
So that's really our mission for this deep dive. We want to give you a direct route to understanding some fundamental Azure data concepts.
Okay.
And our sources today are actually a set of practice questions for the Microsoft Azure Data Fundamentals exam. That's the DP-900.
Okay. So we're kind of reverse engineering the key takeaways from what Microsoft thinks is fundamental.
Precisely. Think of it as like extracting the absolute must-know insights from these questions, a conceptual shortcut.
And just for context, that DP-900 exam, it covers the basics of data in Azure. Microsoft calls it Azure Data Fundamentals. It's usually about an hour long.
Yeah, 60 minutes.
Right, 60 minutes, maybe 40 to 60 questions. You need a 700 score out of 1,000. And I think it costs around, what, $99 US, give or take, depending on where you are?
Yeah, something like that. But the key thing is, while we're using these exam questions, this isn't just exam prep.
Right.
It's about getting that practical, high-level grasp of concepts that matter.
Yeah.
Maybe you're prepping for a meeting or trying to get up to speed on a field, or you're just curious.
Makes sense. The why behind the what.
Exactly. By looking at these specific questions and, crucially, their answers, you'll hopefully get some real insights, maybe a few aha moments about how data actually works in Azure.
Cool, let's do it.
Okay, so let's pick things off. Imagine you're dealing with a massive amount of data, like really massive, big data territory.
Okay. Petabytes, exabytes?
Could be.
Yeah.
And you need to process it super fast using distributed computing, which Azure Service, thinking specifically about Apache Spark, is really built for that.
Right. For that, you're almost certainly looking at Azure Databricks.
Databricks.
Yeah, and it's more than just using Spark. It's an analytics platform that's really deeply optimized, for the Azure environment itself.
Optimized how? What does that mean practically?
Well, it provides this collaborative environment, notebooks and stuff, for teams doing big data analytics, machine learning. And because it's optimized, it makes processing those huge volumes incredibly efficient with distributed computing. It basically manages the Spark clusters for you.
So you focus less on the infrastructure setup.
Exactly. Less managing clusters, more focusing on the actual data science or analytics work. That's a huge win compared to, say, setting up Spark manually on VMs.
Makes sense. So it handles the massive scale. But what if you're smaller? Maybe a startup, just starting with big data. Is Databricks still the answer, or is it overkill?
That's a fair question. It absolutely scales up to petabytes, but it scales down too.
Okay.
It's pay as you go. You can start with smaller clusters, test things out, build prototypes, and then if your data grows, which it probably will, right, then you can just scale it up pretty seamlessly. And actually, the managed environment in those collaborative notebooks, they can lower the barrier for teams who don't have, dedicated Spark experts on staff.
Interesting. So it's powerful, but also accessible. Okay, moving on from processing. Let's talk about storing the data itself.
Right.
We know traditional databases, rows and columns, but not all data looks like that, does it?
Definitely not, especially these days.
So when we talk about Azure Data Stores, what are some key options for that non-relational data, the flexible stuff?
Yeah, non-relational stores are super important for modern apps. Think flexibility, scale. The two big examples you'll see highlighted in Azure are Azure Cosmos DB and Azure Blob Storage.
Cosmos DB and Blob Storage. Okay, what's the difference there?
So Azure Cosmos DB is a globally distributed, multi-model, NoSQL database. That means it's built for non-relational models, document data, key value pairs, graph data.
Multi-model, okay.
Yeah, very flexible, schema agnostic, great for when your data structure might change, during development, agile stuff.
Blob Storage.
Blob storage is different. It's object storage. Think massive amounts of unstructured data.
Like what?
Images, videos, audio files, backups, log files. Huge files, basically. It's great for scale, cost effectiveness, but it's about storing the whole object, the whole file.
Okay, so Blob is like a giant, cheap filing cabinet for files, and Cosmos DB is more like a database for flexible data records you need to query inside of.
That's a pretty good analogy, yeah. If you need to query within the data, like find a specific field in a JSON document, or do complex lookups, Cosmos DB is built for that.
Right.
If you just need to store and retrieve whole files, maybe serve images for a website or archive logs for later analysis, blob storage is usually the better, cheaper fit.
Got it. Store the file versus query inside the data. That helps. Okay, so storage and processing. But what about speed? Like real-time reactions?
Ah, yes. Instant gratification data.
Uh-huh, exactly. Let's say you're building a banking system. You need to spot potentially fraudulent transactions like as they happen.
Okay, critical scenario.
Which data workload in Azure is best for that kind of immediate detection?
For that kind of urgency, you're talking about stream processing.
Stream processing.
Yeah, instead of collecting data into batches and processing it later, stream processing handles data continuously, event by event, as it arrives.
In real time.
Exactly. That makes it perfect for things like fraud detection, maybe IoT sensor monitoring, real-time recommendations, anything where you need to analyze and act immediately.
So it's like watching a river flow by and reacting instantly, rather than waiting to analyze a bucket of water later.
Perfect analogy. It lets you have continuous analysis, firing off alerts or actions based on what's happening right now. You catch issues immediately, not after the fact.
What makes that technically hard, usually?
Yeah.
And how does Azure help?
Well, building and managing the infrastructure for that, the queues, the processing engines, ensuring it's always available and scalable, that's complex. Azure offers managed services like Azure Stream Analytics or Azure Event Hubs. They handle a lot of that underlying complexity.
So you focus more on the logic.
Right. You define how you want to process the stream, what patterns to look for, and Azure manages the plumbing, the scaling, the reliability. It lowers the barrier significantly.
Okay, that makes sense. Now, once we've got all this data processed, stored, analyzed in real time, we need people to understand it, right?
Absolutely. Data's no good if you can't get insights from it.
Especially for, say, business users, managers, executives. They need powerful dashboards and insights, but maybe they definitely don't want to write code.
Haha, yeah, that's a common requirement.
Is there a Microsoft tool specifically for that, graphical interface, no coding?
Yes, absolutely. That's squarely in the territory of Power BI.
Power BI. Okay, I've heard of that.
It's Microsoft's main business analytics tool. It lets users connect to data sources, visualize the data, build interactive reports, create dashboards, all using a drag-and-drop interface.
Drag and drop, no code.
Exactly. That's its key strength. It makes data exploration and reporting incredibly accessible to non-technical users. It really helps democratize data within an organization.
Democratize data. I like that. So it brings insights to everyone. Any common misunderstandings about Power BI? Like, does it do everything, or does it work best with other tools?
Good question. One thing is people sometimes think it's only for small data sets. It can handle large ones, but often for really massive or complex data, you'll use tools like Azure Databricks or maybe Azure Synapse Analytics to do the heavy lifting first, the cleaning, transforming, aggregating.
So Power BI is more the presentation layer.
Exactly. It excels at making that prepared data understandable and interactive.
Yeah.
But the complex prep work for huge data sets often happens in those more powerful back-end services. Power BI consumes the results.
Got it. It's the beautiful front end for potentially complex back-end work.
Yep.
Okay, one last crucial area. Security.
Can't forget security. Foundational.
Right. If you've got sensitive data sitting in, say, Azure SQL database, what's the best practice for authentication? Something that offers centralized identity management and supports modern features like multi-factor authentication. MFA.
Yeah, MFA is critical. For Azure SQL Database, the gold standard for that kind of robust integrated security is using Azure Active Directory authentication. Azure AD.
Azure AD. Okay, so that's Microsoft's main identity service.
Exactly. Integrating SQL Database with Azure AD means you manage user access centrally through the same system you use for Office 365 or other Azure services.
And that enables MFA.
It enables MFA, yes,
Yeah.
but also other advanced features like conditional access policies and just having that single place to manage and audit who has access to your sensitive database. It ties database security into your overall organizational identity strategy.
So it's not just managing database logins separately. It's part of the bigger picture. Why is that central control so important for bigger companies?
Oh, for large organizations, managing identity separately for every single service is just...
So hopefully you listening now have a clearer picture of these Azure Data Fundamentals. And that leads to our final thought for you to consider. Now that you've got this framework, think about it. What other everyday problems, maybe in your work or even just things you observe, could be tackled differently, more efficiently, using these specific concepts? Stream processing, flexible data stores, easy visualization.
Yeah, and what new possibilities does understanding these tools open up for you? What could you build or improve?
Something to chew on.